All right, in this video I'm going to perform a sample calculation from the Spectral Math lab. So if you're at the lab right now and you get stuck on how to do this, you can watch this video and it will show you how to perform the calculations. So the first thing I ask you to do is to look through the spectroscope and draw the lines that you see. So you should see something like what is in this picture up here. And on your spectroscope, it should have, instead of 400 to 700, it'll have like 4 to 7. And there will be little notches in between. Okay, and each one of those represents 1/10. So this would be like 4.1, and this would be like 4.4. This would be about 4.9. And I ask you to draw those lines where you see them, so make a little scale in that long rectangular box, and then draw the lines that you see. Then I want you to select one of those lines. So if we pick, say, this line here, this blue line, that would be roughly at about 4.4, right? 4.4. Which that on the scale that we have is 4.4 times 10 to the negative 7 meters, which is the same as if we look up here saying 400 nanometers. So quite frequently we express light wavelengths in nanometers, and so that's why that unit is given there. And if you look on the back of your reference table, these numbers all here are in nanometers, so they would have to be converted to meters like this. All right, so that would be 440 nanometers. Okay, but we really do want it in this form, in meters. So there are two steps. I first ask you to figure out the frequency and then to figure out the energy. So remember that this number right here is the wavelength of the wave. And the wavelength of the wave can be used to calculate frequency by using this equation where C is equal to wavelength times frequency. And C is a known value. It's always the same, and I will always give it to you on tests. It's 3.8 times 10 to the 8th meters per second. It's the speed of light. So in order to solve this equation for frequency, we're going to divide by wavelength on both sides. And so I end up with C over the wavelength gives me F, right? And in order to calculate that, now I just need to plug in my two values. The C, which is known, so 3 times 10 to the 8th, divided by the wavelength, which is this number right here, so 4.4 times 10 to the negative 7th. And when I do that, I'll get my number for my frequency. So I do 3 e to the 8th, and then I'm going to divide that by 4.4 e to the negative 7th, and I get 6.8 and times 10 to the 14th. So 6.8 times 10 to the 14th. And the unit for frequency is hertz. Now the next thing I asked you to calculate from this is the energy. And remember that energy is equal to Planck's constant times F, the frequency. So I have my frequency here, and this right here is Planck's constant. It's always the same. It's 6.63 times 10 to the negative 34th. And it's joules times seconds. That's the unit, some weird unit. So to calculate energy, I would just take H and multiply it by my frequency, which I calculated here. So 6.63 times 10 to the negative 34th, all times 6.8 times 10 to the 14th. And I already have 6.8 times 10 to the 14th punched in there, so I'll just multiply by 6.63 e to the negative 34th, and get 5.2 times 10 to the negative 19. Or sorry, 4.2. 4.52, sorry, times 10 to the negative 19th. The answer is joules. So in order to get full credit on this, these calculations, you have to show me the work here and put this answer with the correct unit in the first box, and then perform this calculation, show me your work, and put this answer with the correct unit of joules in this box.